Welcome everyone. I'm J Wildberger, and this is a series where we're trying to explain aspects of elementary mathematics from the years K through 6. Today we're going to talk about the time scale of a human life. We're going to start to explore ways in which numbers and a general quantitative approach to things manifests itself in daily life, in different aspects of everyday experience. This is good for young children to connect the somewhat abstract arithmetic and arithmetic rules that they're learning with things that are immediately comprehensible to them. So it's a way of pinning down their understanding and solidifying their appreciation for numbers and the relative sizes of things. So numbers are used for counting and measurement, and today we're sort of moving in the direction of measurement. We're going to be measuring other things as well, but a good place to start is with the measurement of time, because it's something that affects all of us, and that's reasonably easy to understand, even if you feel that you are not very mathematical. Nevertheless, you will have a pretty good sense of time, especially with regard to a human life, which is what we're going to focus on today. All right, so our understanding of time really cannot be separated from a few fundamental astronomical facts about the situation that we're in. So we live on a planet, a round planet, which we call Earth. And now, after many thousands of years of observation and careful analysis, we know that this planet goes around this big star, which we call the Sun. So it goes around the Sun, and while it's doing it, it is also spinning or revolving. So this Earth has an axis, and it's spinning on this axis. Here's the direction of the axis. There's sort of the equator, and the Earth spins in a direction like this, which is sort of a right-handed direction. If you put your thumb with your right hand towards the North Pole direction, then your fingers are curling in the direction of the rotation of the Earth. So the Earth goes around the Sun once a year, and it makes one full rotation around its axis once a day. There's another third player in this story, a smaller player called the Moon. And the Moon is a satellite of the Earth. It actually goes around the Earth. So while the Earth is revolving around the Sun and itself rotating on its axis, there's also the Moon, which is circling around the Earth in a periodic way. Now the direction of the revolving of the Earth around the Sun is also in this sort of right-handed direction. And so is, in fact, the Moon's rotation around the Earth. An important thing to realize is that the axis of the Earth is not exactly perpendicular to the plane of the orbit of the Earth around the Sun. It's actually tilted somewhat, and that's the basic fact that accounts for our seasons. So as the Earth revolves around the Sun, it maintains its axis. So the axis is always like this. There might be the Earth, and as it's going around the Sun like this, that's 1 year, the axis is always still parallel to what it was before, so like this. And that means that relative to the Sun, this situation and this situation are somewhat different. So over in this position here, Australia, which is in the southern hemisphere, gets more sunshine than in this situation over here. So in this situation, more of the northern hemisphere is facing the Sun, while in this situation, more of the southern hemisphere is facing the Sun. And that's the reason why we have seasons. So from the Australian point of view, this would be summer in Australia, and then followed by fall, followed by winter, spring, and then back to summer. While if you were in the northern hemisphere, say in the United States, somewhere up there, then this would be the season of winter to you, followed by spring, summer, and fall. All right, so this is the basic astronomical setup. That's the origin for our most familiar and commonly used units of time, at least time for a larger scale, like a human lifespan. So that was a rather quick introduction to basic astronomy. It's actually a subject that's of quite some interest and importance to young students, the years K through 6. And we will come back to it and talk about that in more detail later on. For today's lecture, all what we really want to extract are the three main units of time that come from the motions of the Earth and the Moon around the Sun. So the relative motions of the Earth, Moon, and Sun give us the three most important units of time. First of all, a day. A day is the time for the Earth to rotate once around its axis. So the Earth is the ball, it's spinning around like this, and it goes around once in a day. A month is the time for the Moon to revolve once around the Earth. So there's the Earth, there's the Moon. The Moon goes around the Earth, and that's typically a month. Well, it's not, in fact, exactly a month. As you probably know, different months have different days. The time taken for the Moon to go around the Earth is about 28 days, which is a little bit less than what we generally call a month now. But that's because we've adjusted our notion of month so that they fit in a nice way into a year. The real month doesn't fit quite so well. You can't pack 12 real months, lunar months, into a year. And so we've modified that for our calendar. But the original notion of a lunar month, which was very important for ancient peoples, had the month at roughly 28 days. And finally, the biggest unit, the year, which is the time for the Earth to revolve once around the Sun. So here's the Earth, and here's the big Sun. Then the Earth goes around that Sun once every year. That's our definition of a year. And that turns out to be 365 days, give or take a few hours. So the day, the month, the year, they all come about from the astronomical motion of the Earth and the Moon around the Earth and around the Sun, respectively. So these three periods, the day, the month, and the year, are not just academically important. They're not just things that we human beings bring to the table to orient our understanding. They are also fundamental drivers of activity here on Earth. So many things on planet Earth can best be explained in terms of the cycles, daily cycles, monthly cycles, or yearly cycles that are generated by this motion. And young people can understand this. They can appreciate that, for example, there's a cyclical aspect to the migration of animals, or birds, or fish. Typically, every year at the same time, certain animals will perform certain migrations. The animals somehow know, the birds know, the fish know that it's a certain time of year, it's time to set off for who knows where, and do the same thing that we did last year, and the same thing that we're going to do the next year. In terms of human beings, the planting of crops is very closely regulated and connected with the seasons, of course. The mating and breeding of some animals is closely linked to the seasons and the time of year. And for us, humans, we recognize that there is a yearly aspect to holidays. Christmas comes once a year, or Easter comes once a year, or whatever religious festivals you celebrate, they come typically once a year. Birthdays come once a year. Taxes, usually due once a year. And the school years that children know all about, year 1, year 2, year 3, these also follow a cyclical pattern, one year after another. So a human life is naturally measured in years. And a human life gives us a good place to get some familiarity with the numbers involved, typically from 1 to 100, when we're measuring events in a lifetime in years. So because our number system is based on 10 and powers of 10, it's natural for us to try to generate other units in terms of multiples of 10. So when we're talking about time, and we want to talk about longer periods of time, longer than a year, it's useful to introduce the notion of a decade. A decade is a 10-year period. Decade, 10 years. And a century is a 100-year period. So a century means 100 years, which is of course the same as 10 decades, because 10 times 10 is 100. That's the biggest entry in our multiplication table that we've learned. So this century is particularly convenient. It's a convenient yardstick to measure a human life, because this is roughly the potential length of a modern life. Roughly, we can expect to live pretty close to 100 years. We may not all live that long, and some of us may in fact be lucky and live a little bit longer, but roughly speaking, this is the extent of time that we can expect, if we're lucky, to live. And especially young people that are being born today, especially in countries that have a reasonable standard of health care, a lot of these people will be expecting to live pretty close to 100, I think. Right? So here is a time scale. It's a line drawn with some equally spaced points, and on this we've put some numbers, equally spaced numbers. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are all separated by 10 each. So this is a decade, that's a decade, that's a decade, and the 10 decades make up a century. That's a century. And we can now look at that and say, all right, that's a kind of a line on which we can pin different aspects of life. We can think about being born here and growing older, 10 years old, 20 years old, 30 years old, 40 years old, 50 years old, and so on, till we're old. And maybe eventually we die. Well, probably for sure we die eventually. So we can say this is the time scale of a human life measured in years, which is a very natural unit to measure in. And then when we look at this a little bit more closely, it's convenient and somewhat arbitrary to divide it into some sections to make it a little bit easier to talk about. So let's agree for this video that youth represents sort of this first part of the time scale, say from birth up to the year 30. It's rather an arbitrary marker here. You might think that 30 is a little bit old to be called youth, but these days, as the life expectancies are increasing, I think it's not too unreasonable to say that youth is the period from roughly birth to 30. And then middle age kicks in, maybe up to around 70. And then from 70 onwards, we could say that that's old age. And the names here are just the standard usage. We don't want to imply any kind of judgments about one particular age being better than the other. Although it's probably reasonable to say that modern culture is rather youth-oriented. But as the baby boomers go through, there will probably be more and more of an emphasis on these latter parts of the spectrum. So there's the time scale of a human life. Now let's have a look at it in a little bit more detail. So here is youth, our first segment of our time scale, from birth year 0 to roughly age 30. And so what I've done is I've taken the first part of that scale and sort of stretched it out and magnified it so that we can look at it in more detail. So aside from the numbers 0, 10, 20, and 30, I've now inserted some more numbers. In fact, all of the numbers from 1 up to 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the first decade. And then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's the second decade. And then 21, 22, 23, 24, 25, 26, 27, 28, 29, up to 30, the third decade. Now, for young people, this is particularly interesting because this is where they are. In fact, the age group that we're aiming these lectures towards is right around here, the primary school years, roughly from 5 to 11 or 12, right? K to 6. But we can start from the beginning. There's rough identifiable periods, the period of being an infant, the first few years of life, and then at some point a child becomes a toddler, and then they go to primary school. And then after primary school, well, generally there's high school, maybe lasting from 11 to 12 up to the late teens. And then there's perhaps college or some kind of training. And then at some point here, it's starting to become more ambiguous depending on where you're living and the cultural background and so on. But generally after the education, then work starts, family life starts, kids arrive. Okay, so along with this very rough demarcation of periods in this range, there's also maybe some other things that we can point to. The teenage years, generally a rather tumultuous, difficult, and very important period in the development of young people when they make the transition from children to adults, often with some difficulty, both for themselves and for their parents. But it's perhaps not bad for young people to be aware that, well, there are these rocky times ahead, possibly, but that they are somewhat finite in extent, and that we can expect that after those years are over, then things become a little bit more smooth sailing, and then life carries on. Right. At 16, people in the Western world often learn to drive, so that's an important date. 18 is often a big birthday where young people get to vote, and in some places they are allowed to drink. Or sometimes in other places that's 21 or 20, depends on where you are. In Australia, age 21 is a particularly important birthday, and that's celebrated more than any other birthday. And so, roughly speaking, the young person, as they merge from the teenage years or adolescence into the 20s, well, their thoughts maybe turn more to dating and mating. They're finding partners here in this decade. That's one of the very important things that they're doing at the same time as finishing their training and starting to work. And some of them will start to have kids in this period too. So that first 30 years, the youth period of life, very busy, very full, lots of things happening, of course. And I think it's good for young people to see a chart like this, so that we see that things are not, we can talk about things not just qualitatively, but also quantitatively. That the structure of these years somehow gives us some information about where we are, where we're going, what we can expect. So carrying on with our time scale, the next phase of human life is middle age. That large intermediate period, roughly from age 30 to, say, age 70, roughly, where young people turn to raising a family. They're married often, they're raising a family, and they're working. So these are the working years, especially around 40 to 55, peak working years. They're often making their most money during this period. They are at the top of their profession, and they have earned a lot of respect, perhaps, and maybe some power and some influence. It's a little bit more difficult to say, well, at this age we can expect something to happen, and at this age something else to happen. Cultural, societal influences here, there's a lot of variation here, so it's hard to make any really systematic, uniform observations. Although we can say that, roughly speaking, around the age of 40, often people will find themselves, perhaps males especially, in a little bit of difficulty. There can be some emotional difficulties there. And generally, I think people who study happiness suggest that perhaps the 50s are one of the more happier periods of life in terms of satisfaction levels registered by people. And of course, eventually we get gray hair and maybe pot bellies, but we also develop more emotional maturity and wisdom. And then near the end of this middle-age period, well, retirement eventually looms, and the kids themselves grow up and often have grandkids. And then we move from that into old age, and there's certainly no clear division here. Things become more general. We're just making very broad statements here. Very individual, depends on people's lives. But generally at this stage here, the latter stage of life, well, there is a slowing down. There are often some health issues. But on the other hand, one is retired. One can have grandkids, and perhaps in this stage, great-grandkids too. Sort of a circle of life type stuff. This is the story of sort of the average person's life, perhaps in the Western world. And so a young person can look at this and say, well, I'm not dictated by this, but roughly speaking, I can expect this pattern to be one that's going to be relevant to me and my friends. And the idea is that these numbers that are associated here allow them to connect numbers to something tangible. So there's a difference between 45 and 55, which they can think about in terms of the difference between being 45 years old and 55 years old. So time is something that we can peg to numbers to solidify our understanding of the arithmetic of numbers. And conversely, the numbers allow us to think more clearly and more accurately about time and the way it's running on in our lives. So young people are often interested in animals, and we can connect animals to this discussion by talking about the life scales of different animals. And there's of course quite a large variation between different kinds of animals and how long they generally live. And here are some numbers that represent maximum lifespans. So generally the longest times that various animals have been recorded to have lived. The bowhead or Arctic whale is perhaps the most long-lived mammal, which can live to more than 210 years. There's a fish, the koi, which is an ornamental carp, which often can live past 200 years. Giant tortoise, of course. They are very well known to be long-lived. They can live 250 years. Less well known, there are these rather large clams that are found in various places, and these clams can live for quite a long time, somewhere between 2 and perhaps even up to 400 years. There's an Antarctic sponge, and perhaps because of the cold waters around the Antarctic, things don't change that much. These are thought to live sometimes well past 1,000 years. There's a lizard called a tuatara, which is some kind of primitive lizard, sort of going back to a dinosaur period, which which lives well past 100 years. And in terms of humans, the record, well, the record that's completely substantiated and that's absolutely certain is 122 years. It's a woman, a French woman who lived around Arles, probably knew Van Gogh, and she was documented to have lived 122 years. There's probably other cases where humans have lived beyond that. I'm sure people have lived to 130 years and probably beyond, but it's a little bit hard to verify these claims because of the long times involved and the memories of the people involved. But roughly, anyway, humans, this is close to being the kind of maximum that we can expect. As opposed to those maximum life expectancies, it's also interesting, perhaps even more interesting, to talk about average life expectancies of different kinds of animals. So, for example, if we take a fox, well, no doubt some foxes die very young, and some foxes might live quite a long time, but on average, foxes live around 7 years. So these figures here have to be taken with a bit of grain of salt. They're, of course, some kind of combination of observations by zoologists and zookeepers. But insects, well, there's quite a range. Insects can live, well, a few days or a few weeks or perhaps a few years. A mouse generally lives around 3 years on average. A fox, 7 years. A blackbird, 11 years. A lion, around 13 years. A cat, a domestic cat, around 17 years. A dog, almost the same, just a little bit more, 18 years average for a dog. A chicken, perhaps surprisingly, can live up to around 19 years. A crocodile, 23 years. A seagull, 26 years. A horse, 28. A bear, around 32. A hippo, perhaps 38. A parrot, 48. A rhino, on average, 52 years. And an elephant, 58 years. And what about us humans? What's the average life expectancy for a human being these days? It's roughly 67 years. Now, if that doesn't seem like very much, one should say that there's a great amount of difference between the life expectancies in the developed countries and in the poor, undeveloped countries, unfortunately. So a lot of African countries, unfortunately, the life expectancy is a lot lower, and that brings this down below what you would probably expect it to be. But in Australia, for example, life expectancy of a male is roughly close to 80 years, maybe 79 years, and a female is typically 5 years more than that. That's pretty usual around the globe. Women generally live about 5 years longer than males. So these kinds of numbers, I think, are interesting for young people. They teach them that numbers tell us something about the world. There's some kind of information that's more precise rather than just talking about more or less. You know, we could say, all right, a parrot lives longer than a gull. Okay, that's some kind of information, but it's somehow more interesting to know that a gull lives on average 26 years and a parrot 48 years. That's quite a bit of a difference. So it's teaching young people about the importance of numbers, and it's also teaching them about the relative positions of numbers. They start learning, yes, okay, the 30s come before the 40s, come before the 50s, and so on. They get a sense for the separation between, say, 32 and 52. Yeah, okay, that's 20 years difference. They start to appreciate what that means. Or that's very important when we go to measuring other things rather than just time. So there are lots of other things that young people want to learn to measure. Next time we're going to talk about some of those other things. We're going to talk about measuring more generally. I hope you'll join me for that. I'm J Wildberger. Thanks for listening.